friends, welcome to CSC Core Concepts in the series of Computer Networks. In this video, we are going to discuss an admission control technique for congestion controlling, that is the token bucket algorithm. In my earlier video, we have discussed about the leaky bucket algorithm, and now we will discuss about a new algorithm, token bucket. Now, this is a technique for traffic management for limiting and traffic shaping that allows for burst of traffic. Still, you can regulate the overall transmission rate. It uses a bucket with a fixed capacity, okay, and there are certain tokens inside the bucket. These tokens are added at a constant rate. Let us say after 1 second, 10 tokens are added like that. So it allows the system to handle short bursts of traffic. So when you have unused tokens have accumulated, while preventing the average rate from exceeding the token refill rate over a longer period. What happens is, whenever any data has to pass, it has to collect a token. Right. But the tokens will be generated only after a certain amount of time. So if there are no tokens, the data cannot go through it. Right. Data cannot be passed to the network. So anyway, it has to wait so that there is no congestion. So here we have to generate the tokens. So these tokens are continuously added to the bucket at a fixed predefined rate. Let's say 1 token per second, something like that. Every bucket has a maximum capacity. So if a token arrives when the bucket is full, it is discarded, but no data packets are lost. Okay. So data packets won't be losing. Then you have a data transmission. So when a data packet or request arrives, it attempts to receive a corresponding number of tokens from the bucket. Now permission to send. So if there is a token available, these tokens are removed. So for every incoming packet, 1 token gets removed, right? And the packet is then allowed to be transmitted immediately. Now if there are not enough tokens, 5 packets have arrived, but there is only 1 token. So the packet is considered non-conformant and can either be dropped or marked for lower priority, or you can better enqueue it and let it wait until the number of tokens accumulate in the bucket. So this is how it is done. Let us see that this is a bucket. Okay, assume this is a bucket having some capacity. This is the host computer which is sending multiple packets. Okay, going on sending packets. So it is an unregulated flow. Means you do not have any regulation that how many packets the source is generating per minute or per second. So this is unregulated. So this bucket has currently only 2 tokens. Let's say it has only 2 tokens. Let us assume it has only 2 tokens, and therefore only 2 packets can come, and when the first packet comes, token becomes decrements. Okay. So the token becomes 1. And when the second packet comes, the token decrements further, it becomes 0. So there are no tokens left for the third packet. And now in this case, this packet either has to be dropped or it can be enqueued to wait until further tokens are added to the bucket. So this helps for a regulated flow. So we keep a variable here that to count the number of tokens. And every t seconds, the counter is incremented. Okay, so if you want to simulate or if you want to write a program for this type of a algorithm, so what you need to do is that after every t seconds, you can increment your counter, token counter by 1, 2, whatever. And then it is decremented whenever you release a packet. So when this counter reaches 0, that means there are no tokens left. And then in that case, you have to wait for making the packet come out. So this bucket, this is the example where there are only 2 tokens and 3 packets are waiting to be sent out of the interface. But 2 packets have only been sent out because by consuming 2 tokens, and therefore 1 packet is still left. So we have to understand what is the basic difference between the leaky bucket and the token bucket algorithm. So both of them are the admission control techniques. They regulate the admission to the network. Okay, by one is by leaking rate and one is by giving tokens. So then what is the difference between them? So the first aspect is the purpose. So the leaky bucket algorithm controls the output rate of the system. one by one the leaks will come, right, based on the leak. And the token bucket regulates the input rate. This is a very important point of difference between them. So token bucket will accommodate inside the bucket. See, in leaky bucket algorithm, if you go through my earlier video, you can understand that there was no regulation on the bucket data, right? A sender can go on sending data to the bucket. Now, as long as the bucket has capacity, it will keep the packet. When its capacity is full, it will spill. That means it will discard them. But here in token bucket, it is not. So you get an admission to the bucket only if there are tokens available. So along with the, so there is a regulation in the input rate also, so that the packets are not lost. So operation is basically, it allows a constant data flow rate similar to the water dripping from a leaky bucket. And here in token bucket, the tokens are added to the bucket, and the incoming packets must consume tokens in order to get transmitted. So leaky bucket is less burst tolerant because it's constant output rate, right? Whereas token bucket is more burst tolerant. What is burst tolerance? So it is the ability to handle sudden changes or burst traffic. So suddenly if there is a huge amount of traffic, then also leaky bucket will do what? It will go and accommodate in the bucket, but it will get spilled. But token bucket will keep it cool. It will keep the number of tokens constant, and it will admit only those packets. So without significant performance degradation or packet loss, or allowing for occasional traffic spikes above the normal rate. So it is more burst tolerant. Now packet treatment, excess packets are either dropped or queued, and here excess packets are delayed, or you can mark them, or you can enqueue them, let them wait. And here token consumption, packets consume tokens, or they do not consume tokens, right, but actually they come out, right? But here packets consume tokens based on their size. So this is how, yeah, so packet will, here they are having tokens at a fixed rate, that is leak rate, right? That only you can consider as a token, but here based on their size, they will consume the tokens. So I hope you understood this algorithm, and basically what is the difference between the leaky bucket and the token bucket algorithm. So don't forget to like, share and subscribe to CSC Core Concepts. Thank you.